Let's take a look at dividing polynomials. Okay. First off, you want to make sure that you've got your polynomial set up in descending order. So you want to make sure that your highest exponent for your variable is at the beginning, and that they go down in descending order. That will just make your setup and your solution a little bit easier. So in this particular problem, we're going to be dividing 6k squared minus 16k minus 1 by 3k plus 1. So the first thing that we're going to look at is we're going to look at 3k and we're going to say, what could I multiply 3k by to get 6k squared? Well, if I multiply 3k by 2k, that would give me 6k squared. So I'm going to put that 2k on my top of my division setup, and then I'm going to take the 2k and I'm going to multiply it by each term in my polynomial. So 2k times 1 is 2k. 2k times 3k would be 6k squared. Okay. Now I want to subtract that polynomial from the first part of my problem. Remember that when we put the subtract sign, that means I have to change the sign of everything in the parentheses. Okay, so I'm going to make that a minus 6k squared and a minus 2k. All right, so I've just gotten rid of my minus sign out here. Okay, minus 16k plus a negative 2k is going to give me a negative 18k. 6k squared minus 6k squared is going to be 0. So at this point, I'm going to bring the next term down, and that's going to be my minus 1. I'm going to do that exact same step again. I'm going to look at my 3k, and I'm going to say, what would I need to multiply 3k by to get negative 18k? If I multiply that 3k by a negative 6, then that would give me negative 18k. So I'm going to take my negative 6, I'm going to multiply it by each term. So negative 6 times 1 is going to be negative 6. Negative 6 times 3k is going to be negative 18k. Once again, I'm going to subtract this term from this. So if I want to subtract that, it means I need to change the signs of everything that goes with this term. So that's going to become a positive 18k, that's going to become a positive 6. Then if I add those two together, because I've changed the signs, positive 6 plus negative 1 would be positive 5. Negative 18k plus a positive 18k is going to be 0. Now there's nothing that I can multiply this 3k term by to give me just 5 because I don't have any k's. So I can't take my division any further, so I would write this as remainder 5. So my answer would be 2k minus 6 with a remainder of 5. You could also put this as 5 still being divided by 3k plus 1. But again, this is the way that your book kind of shows it, so this is an acceptable answer for this particular problem. So especially if 3k plus 1 is not an even factor for this polynomial, this is the best way to kind of set these problems up. It works even if this is a factor. You would just get an answer here with no remainder. So you would know, oh, these two polynomials multiplied together would give me this combined polynomial. This was problem 4.58, so you can check that.